Hello, Algebra 2 Honors. This review of Algebra 1 is just the beginning of our notes of Unit 7-1, the laws of exponents. So just making a quick video to help review our laws of exponents from Algebra 1. So the first law that you should remember is a to the 0 power is equal to 1, and any item to the 0 power, any base to the 0 power is 1. The second law of exponents is when you have the same base, and by base I mean, in this case, the base is x. As you can see, they have the same base, and the power or exponent is what it's raised to. So in this case we have x to the a power times x to the b power. And when the two of the same bases are being multiplied, then you add the exponents. So x to the a power times x to the b power is equal to x to the a plus b power. Our third rule is called the power to the power rule, and that's when you have a base with an exponent that's being taken to another exponent or another power. So here we have our base of x to the a power, and this entire item is being taken to the b power. When this happens, your exponents multiply. So you have x to the a power times b. Our next one that we should remember is when we have the same base and we're dividing the same base, then we subtract our exponents. So when it's a to the m power divided by a to the n power, then it would equal a of n minus n. Our last laws of exponent that we should remember from Algebra 1 is when we see a negative exponent. So in this case, a is to the negative 1 power, and anytime you see a negative exponent, it should signal to you that you need to move it. If it's in the numerator, it gets moved to the denominator. If it's in the denominator, it gets moved to the numerator. In this case, a to the negative 1 power is in the numerator, so the entire item gets moved to the numerator, and you lose the sign of the negative sign. So we could say a to the 1 on the denominator here, and that's just left off because you don't have to write to the 1 power. So a to the negative 1 is equal to 1 divided by a. Okay, let's look at some examples. And I'm going to go ahead and erase a little bit here so you can refer to them without my arrows. And let's look at a few examples. Our first example here, example number 1, we have 6 times x to the 0 power. And notice only the x is to the 0 power. So only x to the 0 becomes 1. So this becomes 6 times 1, which is 6. Now, the difference with our example number 2 is 6a, the entire 6 times a is to the 0 power. So this whole 6a is to the 0 power, so this answer becomes 1, because the entire thing is to the 0 power. Okay. On number 3, we have an example just like our second rule. And we have the same base of 7, and both have the same base, so we will add our exponents here. So 7 to the 4th power times 7 to the 8th power would be equal to 7 to the 12th power. And feel free to stop the video and check that. Go ahead and multiply this out times this, and make sure it equals 7 to the 12th power. Our fourth example is showing an example of talking about the same base. So here we have 5a cubed bc squared times negative 2a to the fourth times b to the ninth. So this is more of an example from Algebra 2 where we'll be using these rules more in depth. So remember how you do this is you look at each item, and first we look at the coefficients. So we have 5 times negative 2, which would be negative 10. And then we look at the same base. So a to the third times a to the fourth. We would add those exponents. So a to the third plus 4. And then we look at the b term, the b part of the term, and we have b to the 1 times b to the ninth. So that would be b to the 1 plus 9. And then here has a c squared, but this item does not. So it will just be multiplied by 1 by itself there. And we would simplify just by adding the exponents here. And negative 10, a to the 7th, b to the 10th, and c to the 2nd. You don't have to write out this step. I just showed it so that if you need to break it down, you feel free to use this step as well. Okay, so that's a more in-depth example of this law. Number 5 is showing you the power rule. So each item within itself is going to be taken to that power of 4. So each item in here, so it's going to be negative 3 to the fourth power, a to the third power times 4. So a to the third times 4 would be a to the 12th. And then b to the 1 power times 4 would be b to the 4th. Okay, so then you would just multiply out negative 3 to the fourth power, and that would be 81. To continue simplifying. So 81 times a to the 12th and b to the 4th. Okay, so that's the examples of the first 3. Let's look at a couple more on these notes. Just look at the last 2 laws. And let's look how those 2 laws we just talked about combined. And then also let's look at number 8. And I think I'll just do 6, 7, 8, and 9. And that should be enough for you to be able to do your homework. So if we look at number 6, we have 2 parts here. And just like in the order of operations, when we have variables, you must do this exponent first. So the power first before you then multiply it by here. So this will get written down why we will distribute this power. So we have 2 to the third power, which would be 8. And then a squared to the third power would mean 2 times 3, which would be a to the 6th. And then b to the 5th power to the third power would be 5 times 3 would be 15. So that would be the first step. And now we have 2 terms being multiplied by each other. So again, we're going to look for the same base. So 4 times 8 would be 32. And then a to the 7 times a to the 6. So here again we'd add the exponent. We have the same base and we're multiplying the same base. So we have a to the 13, and then b to the 6 times b to the 15. We'd add the 6 plus 15, so that would be 21. Okay, so one rule that wasn't listed there but we talked about was how each item will be to this power. So if you have a fraction, both parts of the fraction is going to be to the power. So here our fraction is the entire fraction, both the numerator and the denominator, is equal to the going to be to the second power plus the variable to the second power. So one way you can look at number 7 is first just distribute the power. And we have 3 squared over 4 squared and times x squared. And then we would just simplify our fraction here. With 3 squared would be 9. And 4 squared would be 16, and that's multiplied by x squared. Okay, and we could circle this one too, as well. All right, for number 8, we are looking at dividing here. So just like we would divide the numbers, 6 divided by 4, we'll be dividing the variables. And when we divide variables, remember we subtract the exponents. So first let's think about 6 divided by 4, and we would just try to reduce that fraction, or if we could make it an integer we would, but in this case we can't. We can only simplify by dividing out a 2. So 6 divided by 4 could simplify to 3 halves. And if we look at x squared divided by x to the 9th, we will have x2 minus 9. And I'm going to go ahead and write that out. Okay, and then for the y base, we have y to the 7th divided by y, so it'd be y to the 7 minus 1. And then for the z's, you can see z cubed divided by z cubed you're going to get 1. But let's go ahead and see why this becomes 1. So z cubed divided by z cubed, we would subtract the exponents, and we have z 3 minus 3. So here are 3 over 2. I guess I left off that 2. I didn't mean to do that. So 3 over 2 can't be simplified anymore. Our x to the negative 7, I'm going to write it first on the numerator, then we'll talk about what we do with a negative exponent. And then y to the 7 minus 1 will be y to the 6. And then z to the 3 minus 3 is z to the 0. So a few more things to simplify. First, we were going to move our x term to the denominator because we don't want to leave any negative exponents. So we have 3 over 2, and when we move the x that's being to the negative 7, we move the entire x down and the 7, but we lose the sign. And then y to the 6 still stays in the numerator, and z to the 0 power is 1, so we don't have to write that. Okay, the last example I'm going to go over is another example with negative exponents, just to review that a little bit more. So the first step I always do is I look for this, try to simplify before I do anything. I look to see if there's any of the same base in the numerator and denominator. And in this case, there's not. So now I'm just going to be moving the negative exponents to moving the variable so there's no exponents. So the 3 is fine. And just the x is to the negative 2 power. So that gets moved. So when you move from the numerator to the denominator, the entire item gets moved plus the exponent, but the negative sign goes away. Then if we look at the y to the negative 3rd, that'll get moved to the numerator. So that would be y cubed, and again the negative exponent goes away. And last, z to the 4th is fine on the denominator. It's not negative. So hopefully this gave you enough information to do your homework. If you need more help, please watch the Khan Academy. He breaks down the exponents a little bit more. Have a great night.